Okay, good afternoon once again. Today we're going to discuss a common topic in regression, which is the binary logistic regression. As the name suggests, binary means two. Okay, so you have two levels here for your dependent variable, and this method is used when your dependent variable is not quantitative. Well, it's not continuous. So we said that for multiple linear regression, your dependent variable should be a continuous variable. In this case, binary logistic regression, the dependent variable can take on can take on two possible values only. Okay, so that's binary. So it redounds to a factor actually. So either, for example, a yes or no. Okay, or if you would like to determine whether particular observation should belong to one category versus another. So that's an example of binary logistic regression. Uh, for example, in medical field, you'd like to know, given the vital signs, the body statistics, you'd like to know is this if this person will be prone to cancer or not. So that's an example of binary logistic regression. Or uh, for example, students, you take some details about the students and you'd like to determine if the student will either graduate with honors or not, or pass a course or not. These are decisions, or these are inferences that we'd like to make, and that's only possible if your dependent variable is binary in nature. Okay, so your dependent variable, it's carries on values like 1 or 0, or yes or no, true or false, or category A or category B, or cancer or no cancer, etc. So these types of variables, these types of dependent variables will take on a type of regression called binary logistic regression. So your first case is all about multiple linear regression. And of course, you should, when you choose your data, make sure that your dependent variable is continuous. Okay, obviously, when you choose a data and your dependent variable is either is binary, then that will not do, class. Kasi iba yung model pag binary logistic regression. Okay, so I shared with you a file, binary CSV. So I'd like to suggest that you open a project and then load that data to the project, okay, so that it will be very easy to access that data. Okay, so once you're done, class, once you have opened an RMD file and you have loaded the data, okay, in the folder in your R project, then please chat yes so that I may begin to have our discussion this afternoon. Okay, thank you, Del. So let's wait for the others. Yes, Patricia, thank you. Okay, maybe for some of you, you have already done this topic before. So please bear with us, because I'm sure the others have not done a modeling like this. Okay, all right. Thank you so much. So let's give your classmates a few more seconds before we proceed. Okay, this has always been the case, class, in FINTSAR. There's always a pressure as to be able to cover more materials. Ever since, ganun na talaga yung experience ko dito sa subject na to. And oftentimes I struggle between going very fast so that I'm able to cover all the materials, which runs the risk of sacrificing comprehension or understanding of the students, or just take it slowly and then fail to cover the other topics towards the end. So it has always been one remedy that I have found quite useful in the past, is to is to do some asynchronous class by posting some lessons in Canvas already. Okay, so thank you. Thank you for answering that question. All right. So let's load our data. Let's just call it that. I'm not going to share this code with you. I'm sure you'll be able to run that on your own. So read.csv, and then I'm going to access the binary.csv. And as I said, you don't need to define the location because it's already inside our project. You should find it here among the files. Okay. All right. So let me run this. You may wish to call it any way you want, the object, but for purposes of uniformity and being able to follow along the same code, then I suggest you use that. Okay. That does not have any meaning. No? It's just that. Okay, and we take a look at this. It's under data. It's 400 observations of 4 variables. Let's view this. Okay, so there are 4 variables here. You have the first variable is admit, then GRE, GPA, and then rank. So this is data about which a school gathered coming from its applicants to enter that university. So admit is the variable that records if that student applicant got accepted in that university or not. So 0 refers to not accepted, 1 refers to accepted. GRE is a scoring din yan, no? Scoring din yan used in the US. So 380. The higher the GRE rating, the more academically, let's say academically high the scores of the student is. GRE. And then GPA, you know, this is the GPA from the, I think, senior high school. Okay, and then rank. The rank is the school where the student came from. Rank 1 school means a high-tiered school. And then 4 means a lower rank school. Okay, so for example, respondent number 1 had a GRE of 380, GPA of 3.61, and the rank of 3. And this student was not admitted to the university. So we'd like to use all these 400 observations to come up with a model so that if a new applicant comes and then we have the GRE score, the GPA score, and the rank, we'll be able to predict if that student will be accepted to the university or not. So this is what the problem is all about. It's a prediction of whether the student applicant will be admitted or not to the university. So yung dependent variable natin class is a binary variable. It's actually a factor: 0 not admitted, 1 admitted. So even if it's in integral form, okay, we know that this is not actually an integer. It's not 0 or 1 per se, but rather it refers to a classification. So we know that this is a factor, okay? And then you have your GRE, GPA, and rank scores as your predictors. All right. So this is our data. Okay. All right. So we have viewed it. Let's take a look at the structure of the data. Okay, the structure of the data. It's a data frame, 400 observations of 4 variables. You have here admit, which is an integer, GRE and GPA. Their GRE is integral and GPA is numeric. Okay, so what we're going to do first is, before we convert it into a factor, okay, let's first take a look at the cross tabulation. Okay, please tell me, class, if I'm going too fast, because I'm not going to give you the code. I want you to do something. Okay, I want you to also type the code yourself. So let's create a two-way cross tabulation. Okay, but before we can do this, since we're creating a cross tabulation of admit and rank, okay, we have to do something first. because admit is numerical, okay, and then integer, and then rank is, what's the rank? Rank is also, where's that? Structure. Rank is also integer, okay, and then we don't want them to be treated as integers, but rather as factors. So here, okay, we are accessing this variable admit and rank, and then just convert it into factors. So let's run this class. Admit and rank as that factor. Okay, control enter. Okay, so let's again check the structure. Let's again check the structure class and see. We can now see that admit now is a factor, and then rank is a factor. Okay? So panay factors na siya, no? So since they are factors now, we can create a cross tabulation now. Here, the function is x tabs, and then we're associating admit and rank, and the data is that. Okay, I'll give you a few seconds to write that class to create our two-way cross tabulation. If we run this, you can now see the distribution, okay, from the schools. Yung rank ng school. Once you have done that class, kindly please chat in the chat box so that I know when to continue. Okay, thank you. So let's wait for the others. All right. Very good, very fast class. Thank you. Okay. All right, thank you. Okay, so you can see here that error. My question dito si Edward. When I do that as factors again, okay, wait. Okay, so there's a question here. Thank you for Edward for that question. I'm going to stop share first. Edward, could you kindly share your screen, please? Let's try to decipher what happened to your. Can you share your screen?
Can you see it, sir?
Okay. Yeah, let's see. That admit as that factor error in cache. Okay, attempt to. Wait, may I see your. Asan na yung objects mo? Okay, andyan na yung binary, ano? Andyan na yung dot. Okay. Factor na. Naka-factor na siya. Can you run structure and then yung str dot? You see? Ayan, na-convert na siya. No? Factor na siya.
Okay, sir. Thank you, sir. Sorry.
Diba? Tapos, nung nag-cross tabulation ka, nag-work siya. Can you run the next one? That one. Sige. Oh, nag-work naman siya. Okay.
Thank you,
So,
sir.
siguro nag-strange message lang siya. Pero nag-run naman siya anyway. Okay. Thank you, Edward. Thank you. So, let me share screen again. Appreciate those questions, class. No? All right. So we can see here that si rank 1, no? Si rank 1 school, more than 50% sa kanila ang na-admit, no? 33 out of 61. So that's more than 50%. Only 28 were not accepted, but 33 were accepted. Pero yung lower rank school, tingnan nyo, no? Malaki yung percentage na hindi na-admit. So maybe rank has a bearing on the admission of the students. No? Kasi yung rank 1 school, mataas yung percentage ng acceptance. Si rank 2, medyo mababa din, ano? Almost 50, one-third lang yung natatanggap sa kanila. 50 out of around 150. So around one-third. Pero yung lower rank, mas mababa talaga, no? 28. So less than mga 30% to. Ito, mga 20+% lang. Okay, so you can see the gradation of the percentage of those students that are accepted based on rank. So that tells us that most probably rank is a significant predictor of being admitted or not. Okay, clear yung class? Of course, I'm just guessing based on the that has to be validated. That has to be seen with by our model. Okay, any questions as far as the cross tabulation is concerned? Class, clear ba so far?
Yes, sir.
Okay, good. Thank you. All right. Okay, sige. Let's continue, class. Now we're going to do something which we did not do in your multiple linear regression. I deliberately postponed this discussion, okay? And that has something to do with what we call, okay, overfitting. Okay, let me annotate for a while. The concept of overfitting. And this we're going to meet in, I'm not sure, but although it's not part of this subject, but let's see if we can also have discussion on machine learning. It's more for financial analytics. Okay, but what's overfitting? Overfitting is when we use all of our data, okay, in order to create a model, depending on what we're modeling, depending on the variable that we're regressing. Okay, when you use all your data to create a model, then we might be guilty of what we call overfitting. Why is that so? Because you're now creating a model that's more fit for those set of observations. So in practice, what we do is to split our data. So we don't use all the observations in order to generate a model. What we can do is the data can be split into two. For others, it's three. It depends on the size of the data. For our purposes, we'll just split it into two, and we can create a training data set, train. Okay, so we're going to use the train data set to create a model, whatever regression model that is. And then once we have created that model, we're going to use that model on a data set that has not yet been seen by the model, and that will be our testing data. Okay, and we'd like to see if the model that we have generated will also perform okay, or if it will perform well if it's tested on a data set that it has never seen. When I say never seen, this testing data set was not part of the training data set that we use in order to generate our model. Okay, that's what I meant by has not yet been seen. Okay, so how do we do this? Okay, now the bad practice is a not so good practice is just to, if you take a look at our data, okay, so this is our data. Maybe we'll be tempted, this is 400. So let's say, depending on the size of the data, I've seen splitting your data. If the data is big, then you can split it by 60-40. Okay, some would split it into 60-40. Okay, so it really depends on the purpose of the study and the size of the data. So 60-40 for your training. Some would do 70-30. And if it's a small data set, some would do 80-20. Okay, so it really depends. There's no standard rule for this. Okay, it's usually a rule of thumb. I oftentimes would see a 70-30. For our purposes now, since we have only 400 observations, and around 80% of that will be around 300 plus or so. So around 20% nito will be just about mga 80 plus, 80 or something plus. Okay, so maybe an 80-20 proportion will be just fine. So let's use an 80-20 proportion. Okay, so how do we now split our data into
Sir,
yes?
may I ask them?
Yeah, sure.
When do we actually know that we're using too much observation, sir? Are there any like diagnostic to test it
yeah.
out?
Oo, walang ano eh. Well, I'm sorry, I've tried to look for sa practice walang mga standard usually mga round of figures na ganyan 60-40, sometimes 70-30. So ganun lang nakikita ko, and I've tried to look for sa journal studies, wala pa sila na standard, no? Okay, from what I observed, from what is being done, pag malaki yung data set, kunyari, it's in the tens of thousands, hundreds of thousands, then okay lang siya mag 60-40. Kasi, kunyari, if you have 100,000 observations, 60%, no, that's 60,000, that's quite big already, no? That's big to create your model. And then 40,000 pa yung matitira for your test. But if it's just a small observation, okay, kunyari, 100 lang siya, mahihirapan din tayo. Yan yung mga ganong cases, mahirap din yung 80-20 doon, kasi pag 80-20, 80 yung pupunta sa model, tapos 20 lang yung observations ng testing, that might create some problems. So that's a very good question, thank you. But so far, baka may makita kayo class na masishare nyo sa class, no? Kasi so far I've been looking for that was also my question. Kasi sa machine learning, sa machine learning process to, no? That they do not create a model from the whole set of data. So talaga nag-split, nagpa-partition ng data. Okay, tapos yung pagpa-partition pa niyan class, may mga may mga advanced methodologies yan, but yung mga cross validation, okay, but that will not be part of our discussion kasi it's more of machine learning, no? I discussed that class FinLits, financial analytics, but not so much in regression, but not so much in FINTSAR. Okay? Sorry Adela, I don't have let's say a standard answer for that. Okay?
It's okay, sir. Thank you, sir.
Okay, thank you. I'm just being honest, no? Ayoko naman sabihin na ito dapat ang gagawin, no? I don't want to be too let's say what's the term for that? Anong term sa pagyan? Anyway, ayoko yung maging ay nako. The term escapes me. Anyway, so ganun class. For our purposes now, we have 400 observations, no? And 80% of that 320, okay na yan, no? That will be still fine. And then for our testing data, if 320 yung natin, training, then 80 for our testing, it's okay. It's okay. Kasi ang alam din naman natin sa in most statistical tests, they require that depende din sa number of variables. I would see yung iba basta more than 30 na observations. Ganun yung mga nakikita natin na and statisticians usually have reasons for that. Okay. All right. Thank you, Del, for that question. All right. So let's go here. No? How do we now? Okay, this I want you to copy class or write on your own. No? So we're going to set that seed, okay, para pare-pareho tayo. No? And we're going to use the function sample. Okay, ano yung sample function? Tingnan muna natin. Let's first study that. So sa sa help function, sample. Okay, so this is coming from sa package to sample. This is from base R. Okay, so that's why hindi na natin kailangan tong this is not coming from any specific or particular package. So it's just coming from base R. So what does it do? It takes a sample of specified size from elements of X using either with or without replacement. Okay, when you say so it's just like having an urn, okay? An urn of, let's say, marbles, yung usual na experiment sa statistics. May marbles ka, tapos kukuha ka dun, Some are blue colored, some are red colored, etc. You take you get a sample of one, okay? When you say with replacement, ibabalik mo ulit yun, no? You're going to return that marble that you took. So na-maintain yung size ng marbles doon. Okay? Yung without replacement naman, as the name suggests, of course, pag kinuha mo, well, hindi mo na ibabalik, no? So ganun lang naman 'yon. Okay, so that's one way by which we can create a sample. So this is the syntax, and there are examples here. There's an example here which you can try to run. No? Ito may sinasabi pang bootstrapping, okay, which is really more of some machine learning. No? So we will dispense with that discussion. So simple lang gagawin natin ngayon. Our objective is to be able to partition our data. Okay, so ito, no? I'm going to call this object ind. Maybe it just refers to index, no? And then we're going to use the sample function. Sample into what? Into 2. No? Into 2. So coming from what? How many class? How many? If you take a look at the syntax here. Saan na siya? Okay. Yan, size, no? So X is the number of partitions, the number of samples that you want to generate. Size is, yung size natin is 400, di ba? So it's just the number of rows of our data and that. And then we will use replace is equal to true, ibig sabihin with replacement. And then how will the distribution be done? 80-20. Probability is equal to a list of 80-20. Okay, so let me pause for a while, allow you to at least copy this first two. Pareho na lang yung set.seed natin para pareho tayong splitting ng data. Okay, and once you're done with this first two, kindly chat please so that I can continue. Or well, maybe you can already also write yung train at saka test and I'll explain it. And once you're done with this 4 lines of code, then kindly chat please. Okay, thank you. So let's wait for your classmates. Okay. All right, good. Okay, thank you. All right, so I'll run first yung set.seed at saka yung, okay. Let me show you. Okay, first let's run this. And then let's see what happens to the index, the IND. Okay, so we now have, notice it's not a data frame. The index is a vector. It's a numerical vector, no? Okay, let's print. Tingnan natin kung ano laman itong index na to. I'm going to print it here. Ito na lang, Control-Alt-I, tapos IND, no? Print natin si IND. Okay, what's this class? What do you now have? Okay, you now have 400 observations siya, no? 391, 92, 93 hanggang 400. And then you can now see here on the index of 1 and 2. Okay, so first you have 1, 1, 1, 1, and then 2, 1, 1, 1, 1, 1, 1, 2, 1, 2, 1, 1, 1. So what happened was R created an index for our data set that an index of 1s and 2s. That's used to classify your data. So lahat ng 1 will belong to one group, and lahat ng 2 will belong to another group. So you can now see that this has been randomly generated, no? If we use another set.seed, iba na naman yung set nun. Okay? So ang ginagawa lang naman to, class, parang index siya. Kapag 1 ka, you belong to one group. Kapag 2 ka, we will belong to the other group. Okay? So tingnan nyo to. Ito, this is observation number 1. So yung first, second, third, fourth, they will belong to the first group. The fifth will belong to the second group, etc. So lahat ng 2 will belong to the next group. And you notice there's the preponderance of 1 kasi 80% nga, di ba? 80%, 20% yung distribution natin. So mas marami talaga yung isa, no? 80-20 siya. But that's not exact. Titingnan natin. So let's now create an object. This is now our training data. So lahat ng may index na is equal to 1, i-calculate natin, ilalagay natin dun sa training dataset. So simply the code is yung dot class, okay? And then yung rows will be get the index and equal to 1. So lahat ng index na may 1, okay, dun siya pupunta sa training dataset. Lahat naman na index equal to 2, dun siya pupunta sa testing dataset. So if you run this class, to train, enter, and then test, enter. Okay, so what object is this? So si train at saka si test, they're all data frames, no? Kasi nga kasama lahat pati yung kasama yung variable na admit, GRE, GPA, rank. Kasama diyan, no? Okay, kasama sila lahat diyan. Okay. All right. So tingnan natin yung train, no? View natin si train, dito ko na lang Okay. All right. What do you notice about this? Si train dataset natin. Tingnan yung mga numbers sila, no? 1, 2, 3, 4, 6, 7, 8, 9, 10, 11, 12, 13. Wala yung 14, wala yung 5, no? Bakit? Bakit wala yung 5? Kasi napunta siya dun sa sa testing dataset. Okay, print ko yung test. Tingnan nyo class 325 observations versus 75 observations. Hindi exact na no? It was not exactly 80-20. Kasi 80% ng 400, that's 320. Okay, there's another way if we really want to have a very strict proportion, iba yung gagawin, no? Yung sample randomly din kasi yan. So even the distribution itself is not really strictly 80-20. Okay, if I print yung test natin, okay, tingnan nyo class. This is number 5, yung index natin. Kasi dun sa ind natin, yung number 5 goes to the second dataset, yung testing dataset natin. So here there are 75 observations sa testing natin. Sa training natin, there are 325 observations. Okay? Pause muna ako, class. Please kindly confirm, class, kung nakukuha nyo yung
Sir, may I ask lang, ano pa yung set seed 1, 2, 3, 4?
Sorry, na-unmute ko. Yes, Del, what's your question?
Ano yun po yung set seed 1, 2, 3, 4?
Yung set.seed, this is a random number generator na pag pareho yung number natin, we will have the same same random numbers generated. So example kunyari baguhin ko to 9999, okay? So iraran ko ulit to iraran ko ulit tong index na to, no? Here, I'm going to run this again. Rerun this. Iba yung set.seed ko, no?
So, sir, it's actually okay to put any number, pero just for the purpose of
any
this
number,
class.
pwede. Yeah,
1,
but
2,
for
3,
the purpose, so that we have the same we have the same data set. Let me just complete that answer. So pag rinan ko na tong ind na to kasi nag-create ako ng ind dun Okay? So iba na class yun nyo. Okay, di ba? Yung una ko na dito 2. Tapos 1 1 2 1 1 2. It's already different. So had we used this yung 9999, iba yung training and testing data set natin. Okay? Will we be able to generate the same model? I don't know. Maybe different, no? Maybe different. Okay. So ibabalik ko yung ibabalik ko yung 1 2 3 4 para pare-pareho tayo.
Does it also have to be 4 numbers, sir?
No. Can be 3.
Sige, sir.
Can just be 2 numbers. Walang siya. Wala siyang rule on how many. Okay. Set.seed. Okay. So balik na tayo sa pareho, no? Pareho na yung natin, yung let me check yung in. Wait. I-print ko ulit siya, no? Okay, wait. Dali I-run ko na lang ulit ito lahat. Okay, then my end will now be, ayan, tama na, 1112, 111, pareho na tayo. No? Okay. All right, so let's now go to the modeling. Okay, so we have learned that in R, we use the LM function. So let's create this object, my model, or you can name it any way you want. So I just use my mod, LM, then we regress admit on GRE, GPA, rank, okay, the three predictors, and then data is equal to, now take note, we're just going to use the trained data set. We're not going to use the original data set, which consists of all your observations. Sabi natin, we would like to avoid overfitting. Okay. All right. So we're going to use the trained data set that we generated a while ago when we split our data into two. So the objective is we'll run it using the trained data set, check how our model performed, and then rerun it using this time the test data set, and see if our model was able to predict as accurately as possible yung test data set natin using the model that we generated using train. All right, so let's run this class. Again, I'm not going to share this code with you. Kindly write the code. Okay, you may name it any way you want, but I suggest pareho na lang para pag-copy nyo, when you're copying, you don't have to think about the name that you used. Okay, so I'm going to run this and then summary na natin. All right. Okay, now what does it say, class? Did you get this warning, class?
Yes, sir.
Yes, sir.
Ano sabi sa warning? Warning, using type is equal to numeric with a factor response will be ignored. Not meaningful for factor, not meaningful for factors. In other words, class, the LM function, okay, the LM function will not work if your response variable, if your dependent variable is a factor. Diba? We converted this into a factor. You cannot use the LM function. Okay, so there is another way to do this, and we're going to use what we call the GLM, the generalized linear model. Okay, so sige, tingnan mo natin, class, kung ano yung ginagawa ng GLM. Okay, GLM. Question mark, GLM. All right, so this is from the stats package. Okay, so fitting generalized linear models. GLM is used to fit generalized linear models specified by giving a symbolic description of the linear predictor and the description of the error distribution. Okay, so iba't ibang klaseng GLM, no? So this is the generic syntax. Okay? And then dito, class, meron tayong mga details about it. Okay, so let me just point out, class, that okay. Asa na dito? Wait. Okay, saan na siya? Okay. Where is that? Dali lang, hindi ko makita yung different types of dependent variable that we can use for GLM. Saan na yun? Okay, I'm missing it. Okay. Saan na siya? Family, ito. Okay, so I think I have to click this muna. Family of details of family functions. Click ko. Ayan, class. Okay, dun sa family, no? So you can have their binomial, okay, Gaussian, gamma, inverse gamma, etc. So these types of nature ng dependent variable natin, okay, may be used. Okay. Pag ganyan na class yung attribute ng dependent variable natin, we cannot use the LM function. For example, yung sa atin ngayon, binomial siya, di ba? Kasi 0 or 1 lang yun. Factor siya na 2 levels. So we cannot use the LM function. Okay? And there are other functions, there are other types which is really outside the province of this course. So hindi natin titingnan yung mga iba dyan. Okay? But we're just going to focus on maybe also multinomial, titingnan din natin. Okay, pag multinomial class naman, ang difference siya sa binary, pag multinomial more than 2 yung yung factors natin, no? Kasi ang binary dalawa lang. 0 or 1, true or false, etc. Pag multinomial ano na? More than 2. Okay. Dalang class, I'll just get water. Okay. All right. So, what changed now? I-redefine natin yung model natin, not as LM, but rather as GLM. Pareho pa rin yung regression natin, model, data is equal to train. And then we have to identify here the family. Kasi di ba maraming families to, di ba? May Gaussian, may gamma, may inverse Gaussian, Poisson, okay? May quasi-binomial pa, may quasi-Poisson. Will a numeric, good question. So you mean to say yung yung regular na multiple linear regression? Do you mean that, Del? Okay, so that's a good question. So we will ask Del to discover yung wage, no? Yung wage na model natin dati, if using GLM will work there, no? And then that's your assignment, Del. You will have to tell the class kung instead of using the LM dun sa wage function natin, mag-work ba yung GLM? Okay? Sorry, nag-assignment ka tuloy. But that's good. Thank you for that question. No? Okay, I already tried that before, no? But I want you to discover it. Okay? All right. So ang question ni Del, paano yung dati, no? Yung wage data set natin? I think umabot tayo ng model 4 or model 5. And then we were regressing hourly wage on education, ano pa yung etc. Di ba? Apat na variables yung natira. Okay, so will that work if we use GLM? Okay, so that's a good question. So assignment ni ano yan, ni Del. I-report niya sa class next meeting yan. Okay, so sige. So meron na tayong na-run nyo na to. May summary na tayo, no? I-run ko yung summary class. Okay, hindi ko pa pala na-run. Ay, wait. Okay. So binago ko na yung pangalan dito, class, no? I just choose this, yung my mod, kasi I just wanted to illustrate na this will not work. So medyo hinabaan ko lang yung name ng my mod. So dito, ginamit ko na yung model name. So let me run this. Okay. All right. Okay, so we can now see here, parang pareho lang naman yung di ba? Yung result ng regression. Okay? So we now have GRE. GRE is not a significant predictor of admit. So dito, rank 2, okay, ibig sabihin nun, since hindi siya significant, wala siyang statistical difference with rank 1. Pero si rank 3 at saka si rank 4, no? Tapos ito negative 1.12 tsaka negative 1.53. Now, hold your horses, class, kasi iba yung interpretation nito, no? Whereas sa LM, pwede nating idiretso, no? Ano ba yung ibig sabihin itong negative 1.5? Sabihin natin, on the average, rank 4 students are admitted by negative 1.553 times less than their rank 1 counterparts. Parang ganun yung yung interpretation. On the average GPA, a 1 unit increase in GPA, a 1 point increase in GPA will increase the rate of admission by 1.17 times ceteris paribus. Okay, so ang question, is that the way we interpret this? Okay, the answer is no, class. There's a different way by which we interpret this estimates. No? All right, so meron pa ditong null deviance, which we're going to discuss later on. Okay. All right, so what do we do now, class? We notice that, okay, z value to, no? Hindi sa t value. Sa z value, class, the least, no? Kasi mag-ano tayo dito, magsi-stepwise tayo dito, no? So, actually, si GRE lang naman yung hindi significant, di ba? Rank is significant. Kahit na si rank 2, hindi significant. But the other levels are significant, then significant na yung buong rank na yan. GPA is significant. Since we only have 3 variables, GRE, GPA, and rank. So what we do is, we create our final model by removing GRE because it's not significant. Di ba? Isa lang siya. No? Isa lang siyang hindi significant. So, okay. Let me give you a few seconds to run this. Copy nyo lang, class, tapos may gagawin tayo doon. Anong gagawin natin doon? By the way, ito, class, no? I think I discussed this with you before. Okay. What if I want rank 1 to be included here? Kaya lang naman siyang walang rank 1, class, kasi ine-estimate pa natin yung intercept. Pwede naman natin hindi na pa-estimate yung intercept, masasama yung rank 1. So if we want to do that, then ganito yung code niyan. No? Admit regression everything. Okay. -1 here stands for wag isasama yung intercept. Okay. So if we put -1 there, then it will generate another model where rank 1 up to rank 4 are included, and then there's no intercept. Pareho lang siya, class. Pareho lang ng result. Okay? Kasi ito, remember when you interpret rank 1, you include the intercept there. Okay. So if I run this, just to illustrate to you, okay, di ba wala na yung yung intercept, no? Itong sa rank 1, actually, class, -5009514, if we take a look at this, ito yun, no? Di ba? Kasi si rank 1, that's the coefficient of rank 1 when all the others are 0. 0 to. So ang matitira lang to 5009514, di ba? So which is precisely this one. Asa na siya? Wait, sorry. Ito. There. Okay, pause muna ako, class. Any questions so far?
Yes, sir.
Yes?
Didn't you mention, sir, that if we did change the random seed variable, it could change the actual model, sir?
Pwede, no? Kasi mababago yung natin eh. Mababago yung test dataset natin at saka train dataset. That's possible. So that's one difficulty here, no? Kasi so let's do this, class, no? Siguro gawin natin, class, ganito, no? Let's see if something will change if, okay. Ang gagawin natin, okay. I was thinking of running this, having a different set.seed. Sige nga, class, copy muna natin to, no? Ulitin lang natin. Ito na muna. Dito na lang natin i-run, class, no? Dito na lang sa sa console na lang, Control V. Oops, mali. So ang question kasi, what if we have a different set.seed? Okay. I'll copy this, ito. Control C, Control V. Tapos ibahin ko yung set.seed, no? Let's say 111, okay? And then just to distinguish it from the others, gawin kong train 1, test 1, ha? Para hindi na natin mawala yung, kasi pag ginawa kong train, ma-overwrite yung unang train natin. Okay, so let me run this. Control Enter. All right, so meron na akong train 1, test 1, no? And then let me create now a, dito na, no? Here. Okay, ito class. Control C. Control V. Okay, so I'm now creating, let me call this mod 1, GLM, and the data is now train 1 para separate yung data na to. Family binomial mod 1. Okay, I'm just going to compare class. Kung magkaiba yung ano natin, yung set.seed, kasi a different set.seed will generate different sets of train and test data set. Okay, so okay, i-run ko to. All right, and let me see the model that was generated. Okay, intercept was the same, no? Okay, 166,408 yung GPA. Hindi rin significant yung GRE. Okay, pareho ba class yung sa GPA?
Yes, sir.
166, GPA is 408. Pareho lang, no? Okay. Tama ba tong model ko? Tama, train 1 eh. Magkaiba ba yung ano? Magkaiba ba yung... Yeah, magkaiba yung test 1 at saka train 1 ko, no? Train 1. All right. So, surprising, no? Practically the same sila, di ba? Am I right, class?
Yes,
Magkaiba
sir.
po ata yung rank, sir.
Sa rank magkaiba. 55804 dito.
Ay, same lang, sir.
Same lang? Okay. So pareho lang, no? So ang suspicion ko niyan, yung kasi 'di ba 400 lang yung observations natin. So possibly yung napunta dun sa ano sa train 1 natin, halos ano lang din, halos kompleto lang din. Kasi konti lang natira sa ano eh. Konti lang natira dun sa test natin, no? So if most of the observations were anyway loaded to the train data set, so baka hindi siya masyado naging material in having a difference in the estimates, no? I think that's the reason kasi maliit lang yung data set natin. So 325 yung train natin. If there will be a difference, hindi mo siya masyado marami, no? Not many the difference will not be that great kasi 75 na lang natira dun sa isa. Siguro my belief is there will be some differences if you have a huge data set, no? Tapos kunyari 100,000. Tapos 60% 40% kunyari. So yung 60,000 na yun class at saka yung test na 40,000, okay, pwedeng malaki yung discrepancy dun sa sa pagsa-sample natin, no? Okay? Dito kasi maliit lang 325. Okay? There's a maliit lang yung natin, training natin. So pati yung natin, yung testing data natin, maliit lang, no? So that's the reason why okay, that's my guess, no? Yung rank 4 ba pareho lang? 1532942. Tama class? Pareho lang yung rank. Sana siya? Rank 2. Rank 2 is rank 3. Rank 4 15 32942 15 parehong-pareho no? Okay. So maybe we can still look at other combinations ng set.seed, no? But thank you, Del, for that question. That's a very, very critical question, no? So maganda yung question na yun kasi tama nga naman, di ba? Ang issue nito. So pag nag-iba pala ako ng set.seed, yung iba na yung magiging model natin, di ba? So it becomes quite arbitrary. So depende na lang dun sa sa set.seed na random number generator na we're going to use. So that's a concern, no? Especially if, for example, if yung data natin, yung ginagawa natin ng statistical analysis, very critical. Kunyari, ang pinag-uusapan natin dito, i-admit ba yung tao sa sa hospital o hindi based on this modeling. Okay, so some models, of course, will be more critical than others. Wouldn't the difference po affect? Yeah, ito yung question mo kanina, no? Okay, did that answer your question? Kasi isa lang sinubukan natin. Maybe pwede din natin experiment. Will this hold true to the other set.seeds? Okay, kasi pwedeng I recall pala dati may ginawa akong gantong klase na I tried to use a different random number generator and I got a different model, no? Hindi naman siya masyado nagkakalayo. Not enough to make a dent, no? But again, if I recall right, class, it was because of the sample size. Kasi pag medyo maliit yung sample size, tapos ang liit lang kasi ng ng pinagkukuha ng data natin. So chances are kung may difference man, hindi masyadong material yung differences. Kunyari, siguro 10 observations ang napunta sa testing dataset na napunta na nanggaling sa training dataset. Right? You get what I mean? Kung 10 lang ang difference, you have 325 observations and then you have 10. Remember na parang weighted least squares to, no? Kung konti lang yung difference dun sa pag-train at saka sa training at saka testing ng dataset, yung split niya, then it might not make much of a difference. And besides, sa logistic kasi, which I'm going to discuss in a while, we're looking at log odds, no? Okay. Maybe for dun sa multiple linear regression, okay? I did that with multiple linear regression, yung sinabi ko na medyo may konting difference. Okay? So, of course, class, yung multiple linear regression natin, pwede nyo ring split yung data na yun, no? I think we had 526 observations, but all of it we loaded to one. Hindi tayo nag-test and train doon. So you can do that dun sa na yun, sa wage data set. Okay? Del, did that answer your question?
Sige po, sir. Thank you, sir.
Hindi ka satisfied, ano?
It's okay, sir.
Pero we tried, di ba? And it turns out na pareho eh. So ang suspicion ko talaga niyan, yung sa sampling natin, hindi siya masyadong hindi masyadong different yung deviations niya. Okay? All right. Sige. Let's continue with this one. Okay.
Sir, last na po, sir.
Yeah, sure. Go ahead.
Just in case, in a quiz, an example, would you give us the set seed po? Or do we have to determine?
I will kasi mahirapan ako mag-check kung kung iba-iba, no? Diba? Kung iba-iba yung set.seed nyo, tapos iba yung lumabas sa mga answers, it will be more difficult for me. So kung pare-pareho lang, at least isa lang yung tinitingnan ko. Okay. All right. Sige, let's continue, class. Where are we? Okay, we're here, no? We are here. Okay, for this one, we remove GRE. Okay, so we're going to create now a model where we're regressing admit just on GPA and rank. Same thing, data is equal to train, family is equal to binomial. Okay, and we still use the mod. So we're just overwriting yung initial na mod model natin. Okay, so let's run this and let's see what happens. Okay. All right, so we have this one. Okay, so GPA is significant, rank is significant. Okay. So this is our final model class. So how do we interpret this? Kasi ano to class no? Yung logistic regression to. So there's a difference between the model for logistic regression, okay, and your multiple linear regression. Okay, let me explain first. But before we do that, okay, mag-create muna tayo ng prediction. Okay. Let's see how effective our model was. Okay. So tingnan natin So I'm creating this object P1 and I'm using the predict predict function. So i-generate natin lahat ng mga predictions ng model natin. So our model is coming from the mod object. Okay, this is our this is our logit model, and then the data is trained. The type is, okay, I'll explain this as we go along, yung response. No? Okay, then i-print natin P1, okay, head lang, okay, and then i-print din natin yung head ng train. Okay, I'll give you a few seconds to copy this first, and then let's run this and see what this generates. Okay, when you're done, class, kindly please chat yes, so that I know if you're done already. Okay. All right. Sige, run ko to Okay. So what do we have here?
Data frame, sir.
Okay, data frame to ni head, di ba? Okay, so si head, si train class 0, 1, 1, 1, 1. So the first observation is hindi admitted. And then yung second, admitted, 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 admitted. Okay. All right. Take a look at this. No? So 0.282, ito yung head ni P1. Ano si P1 class? We use the predict function. We use the predict function of our regression model, si mod. And then, anong data na ginamit natin, di ba yung train? And then type is equal to response. All right, what's this? 0.282, 0.299, 0.682, 0.129, etc. Now, what are these class? Ano to mga numbers na to? What are these numbers? Anyone? All right, sige, let's first evaluate this. Ano tong 0.2822 na to? Okay, let's copy our model. Okay, ilagay natin dito Okay. Ano na lang natin? Control Alt I. Then you have mod dollar coefficients. Oh, sorry. Coefficients. Okay. So ito yung ano natin class, di ba? Ito yung I'll copy this para mas madali class. Control C and then okay. So ang gawin natin class, let's take a look at data number 1. Ito si data number 1 class. Hindi siya na-admit, di ba? And then ang GPA niya 3.6. Hindi na kasi natin ginamit si GRE. So let me just copy this. 3.61 at saka 3. Control C. Lagay ko siya dito Control V. Okay. So this is our intercept. And then this is our GPA. 1.3735 times GPA. So what's the GPA of response number 1? So we're going to add this. Okay, we're going to use the coefficients class and substitute yung value ng GPA at saka ng rank, no? So GPA is the coefficient is 1.37, and then we know that si observation number 1 is 3.61. Control X. I'm going to copy this and multiply this with this one. All right, how about this? Si observation number 1 is rank number 3, di ba? Ito siya. So si rank number 2 times 0 siya, hindi siya papasok, di ba? Kasi itong coefficient na to, negative 0.57, this is if it's rank 2. Rank 3 ba siya? Yes. So papasok siya, no? It will enter the picture. This coefficient will enter the measure for observation number 1. Rank 4, hindi siya rank 4, so times 0 to. Okay. So what have I effectively done? I'm using now our model, yung coefficients ng model natin, to compute for the predicted value of observation number 1. Di ba? Ang inuna ko si observation number 1, ito. With a admit, no? Hindi siya na-admit. GRE niya, 380. But this did not enter the picture kasi drinap natin GRE among the predictors. Ang GPA niya, 3.61. Ang rank niya, 3. So therefore, dun sa model natin, so this is, ito, no? Intercept kasali, GPA kasali. Rank number 2, hindi siya kasali, kaya tinimes ko lang ng 0. Rank number 3, kasali siya, so times 1 yan. This will enter the picture. Rank number 4, hindi siya kasali, kaya times 0 siya. Alright, if we perform that model and we run this, okay, what do you get? Okay, it's negative 9.331028. Okay, kindly tell me, class, if you're able to follow that. Negative 0.9331028. Let's wait for the others. Okay, good, good. Yeah, good. Thank you. I hope the others are able to follow. Okay. Okay. All right. So, teka muna. Bakit ang value ni number 1, negative 0.933? Eh, dito ang value ng number 1, yung sa predicted, di ba? 0.2826. Yeah, check nga natin. Let one more time. Okay, I'll go here again and create another code chunk. Control 1. And then, si mod. Ano yung mga values ba niya? Okay, ito class, fitted values. Ito yung mga predictions, no? So, sige. I-ano ko, i-run ko to, tapos ano lang, yung head nito, yung first ano lang, first 6 observations, comma, 6. Okay, let me see, pwede ba to? Head ng, yan, pwede, I think. I'll just ask R to generate the first 6 values. But effects, hindi effects. Not effects, but fitted values, F-I-T-T. Yan, fitted values, yung predicted values. Right? Let's run this. Okay, yan, class, oh, ito. Yung predicted values. No? 0.2822956. Okay, where in the world? Bakit? Nung sinubstitute natin yung mga values ng mga ano natin, class, they're not the same. So, negative 0.933. Ito, 0.2822956. Okay? Which actually is, class, 0.28 is the probability, no? So, which means ang probability na si student number 1 dito sa trained data set will not be accepted. Tapos, ang actual value is 0, which means tama, no? Hindi na accept. Okay, pero si student number 2 na-admit siya. Pero ang prediction natin dito, class, is hindi siya na-admit kasi less than 0.52 no? 0.299 or practically 0.3. So this student was not accepted. Okay? Yun ang prediction natin based on the model. Pero yung actual value, natanggap yung student. So maling ano to, no? Maling prediction to. This is an error term, an error prediction. Ito naman class, si student number 3.68. So greater than the probability that this student will be accepted is 0.68 according to our model. Okay? Natanggap ba yung student? Natanggap. So tama, no? So tama ito. So yung first thing natin makikita na tama yung una, mali yung pangalawa, tama yung pangatlo, no? So you can see here na tama, mali, tama. Okay, now that brings us to my question here, no? Bakit based on the values of our model, itong mga values na to, di ba? Ginamit natin to, intercept plus yung GPA, hindi na natin sinama to, di ba? Hindi ito yung final model natin. Ang final model natin, where is that? Okay, nabura ko na yata. Okay. Intercept, GPA, rank 2, rank 3, rank 4. And then when we use the data for person number 1, okay, who is rank number 4, rank 2 and rank 4 will of course cancel out. Kaya times 0 lang yan, times 0. Ang papasok si intercept, papasok si GPA. Ang GPA ni student number 1 is 3.61. So that's why we multiplied it with 1.373. The final answer is negative 0.93. Pero yung fitted values natin, 0.28. Okay? So, paano yun, class? Bakit magkaiba itong negative 0.933? Okay? Bakit? So, the answer lies here, class. Andito. No? Share ko sa inyo itong ano na to, itong code chunk na to. Pakilagay na lang, class, sa ano? Sa notes nyo. Okay, please copy that. All right. And the answer, class, is here. Okay. The value y, class, the value that we get here, y, which is equal to our intercept plus beta 1 times, di ba yung mga coefficients natin, minultiply natin, pinorform natin to. No? And it's equal to y. But y there, class, is not the same as the y in multiple linear regression, where the y is the value of your dependent variable. Ito hindi, class. The value of your y in a GLM, generalized linear model, where the family is binomial, the value of y is your log odds. Ang tawag dyan, log odds. Okay, it's almost time. Okay, so let me just write this. Y, ito yung y admit, di ba? Admit or not. And it's not equal to yung value ng 0 or 1. But rather, this is called your log odds ratio. Okay? P is the probability of being admitted, accepted, and divided by 1 minus P. That's the probability of not being admitted, di ba? If P is the probability of being admitted, 1 minus P will be the probability of not being admitted. And then, kinuha yung log niya, ln. So this is what we call the log odds. Odds kasi, you're getting the ratio of your probability of being accepted over not accepted. This is your log odds ratio. Okay? So it's already time, class, and next time, class, we're going to show that this one, okay, okay, from here, class, you can show that P is equal to ito. Dito, class, linagay ko na rin dito, which I'm going to share with you also. Ito, class. Share ko na rin sa inyo to. And let me end here, class. Control C. So discuss natin to next meeting, and then that will complete our logistic regression. All right. So papakita ko na lang sa inyo, class, next meeting that yung formula natin, yung y natin, ba? Okay, again, one last time, class, before we go. Our y is equal to, di ba, ordinarily, this is your beta null plus beta 1, x1 plus beta 2 x2, etc. In logistic regression, this y class is equal to this, pero it's equal to, it's not the value of your y, it's actually your log odds ratio. So it's equal to log of p over 1 minus p. And next meeting class, ipapakita ko sa inyo na masosolve natin si p kasi ito yung kailangan natin eh. Kailangan natin malaman yung probability na matatanggap ba si student number 1 or not. Okay? And one last thing class, paki-perform nyo nga to. Okay? Paki-solve nyo lang, 1 minute lang to, no? Yan, gawin nyo to class. Yung y natin kasi alam natin yung negative 933,165. This is your y. Okay? But you will have to convert this into a p-value kasi log odds to eh. So how do we convert this into a p-value? Using this formula. So pakiano nga class, e to the y over 1 plus e to the y. So ganito lang class sa Excel. Exponential exp ng negative 0.933 divided by quantity 1 plus exponential ng negative 0.933,165. Paki nga class. Kindly do that please. And then let's call it a day. Thank you so much even for your patience to Ayan, nag-answer na si Lorena. Thank you. So Lorena was able to show 0.2822 nga no, which is the probability class kanina dito. So ang binibigay sa atin ni R is not the value of y but rather the probability of p, the p already, no? So kinonvert na sa atin. Ginawa na niyang sinolve na niya. So once R was able to solve for y, which is this one, kinompute niya using this, and then ang ibibigay niya yung p-value, which is e to the y, your y is ito, yung sa equation natin, over 1 plus e to the y. Okay, paki-confirm nga lang class if you get point. Sila Ray na lang ba? 0.28. Okay, same answer. Thank you, John. Okay, how about the others, please? Okay, same. Good, good. Okay, a few more. Yeah, good, class. Yes, good, good. So, I'll stop share now. Stop recording.